This is a little bit of a stoichiometry problem dealing with gases. So it's asking what we would get with the excess hydrochloric acid, that means we get to ignore it in the stoichiometry, reacting with 0.30 grams of magnesium. So we're looking at that reactant, and we're trying to find out how much hydrogen gas in that volume, decimeters cubed, we get. So we're looking for that product. They've given us a balanced equation already, so that's our first step of any stoichiometry and most chemistry problems in general, is a balanced reaction. Or balanced equation, check, that's good. And we see that there is a 1-to-1 ratio between magnesium, so 1 mole of magnesium for every 1 mole of H2. That's the stoichiometric relationship between the two. So we see that our given is 0.30 grams of Mg, and what I want is decimeters cubed, which is, in other words, a volume of H2. So we can start by writing out our given, 0.30 grams of H2. I want to get rid, of Mg. I want to get rid of Mg and get myself to H2. So I do that by looking at the periodic table. And when I find magnesium on the periodic table, I see that I have, for every 1 mole of magnesium, a mass of 24.31 grams of magnesium. I have successfully gotten rid of grams of magnesium. I'm now to moles of magnesium, which means I'm one step closer to hydrogen. And again, my ratio here, 1 mole of magnesium for every 1 mole of hydrogen, I would put the 1 mole of magnesium on the bottom and the 1 mole of H2 on the top. My moles of magnesium cancel out, and you can see that the 1's cancel out as well. And I've successfully gotten 2 moles of H2. Now they give me one other important piece of information here, and that is that the standard temperature and pressure, the molar volume of an ideal gas is 22.7 decimeters cubed per mole. And so, using that information, I can get successfully to a volume in decimeters cubed, which is what I want, of my gas, H2. So I would put 1 mole of H2 on the bottom. Oops. That's this bottom part here. Moles to the -1 means that it's on my denominator. And the 22.7 decimeters cubed would go on top. So my moles of H2 are successfully gone, and I am left with the following numbers: 0.30 times 22.7 divided by 24.31. In other words, my answer is B.